So this example here is going to be really cool because it's going to combine multiple topics. So we have quadratic equations here, and we're asked to find the inverse function, which is going to introduce our square root function. But also you can see that we have multiple transformations that are present in this quadratic equation. So we're going to see how an inverse function actually reflects and represents those transformations after inversing. So we're going to combine multiple topics together: inverse functions, transformations, square root functions, and quadratic equations as well. So if f of x is equal to 1/4 outside of x minus 2 squared minus 1, and we're given a domain as well, we're asked to determine the inverse rule of the function and therefore sketch both the f of x and f inverse of x on the same axes. So we have to kind of recall some of our inverse knowledge, but don't worry, we're going to go through it step by step and show you exactly how to do this one, because obviously inverse functions was taught a little while ago, so if you don't remember it, that's all good. This should be somewhat of a refresher. But before we kind of continue, it's actually important to note, or it's good to note, what transformations are present here from our basic graph of y is equal to x squared. So this 1/4 here, what does that represent? This 2 and this -1, what do they represent as well? So you should recall that this 1/4 on the outside is the same as a dilation by a factor of 1/4 from the x-axis or in the y direction. This is a translation of 2 units to the right because we're minusing it inside of our function, and this is a translation of 1 unit downwards because we're just shifting our whole equation down by 1 unit. So just keep in mind those transformations that I've mentioned, and we're going to see how they're actually reflected inside of our inverse function, or how they're actually represented inside of our inverse function rule, which we can kind of guess is going to be a square root function because this squared usually becomes the power of 1/2. So if we don't get a square root graph, then we've done something wrong with our algebra. So let's do part A first of all. So part A here. Determine the inverse function, so we always follow the same first step. You specify that you're solving the inverse function and then you swap x and y. So I'm just going to include a little statement here: inverse swap x and y. Hopefully it's big enough. I just want to keep in mind that I don't have a lot of room on this whiteboard here to do both questions, but we'll try our best. So inverse swap x and y, so we end up getting x is equal to 1/4 y minus 2 squared minus 1. And then we just go ahead and rearrange for y. So the first thing we want to do is just multiply we want to get rid of the -1 there by adding it to both sides. So x plus 1, and then we multiply by 4 to get the 1/4, get rid of the 1/4 on that side. So we end up getting y minus 2 squared. I just did them both in the same step to save some space. Then get rid of the squared by square rooting both sides, and just keep in mind whenever you square root, don't always just take the positive, even for square root functions. We know that both the positive and the negative can't exist, but just take the plus or minus for now. And then we're going to use external information to help us find out which one is actually valid in this case. Then we get 4 outside of x plus 1 is equal to y minus 2. And then the last step is to say, well, y is equal to plus or minus the square root of 4 outside of x plus 1 plus 2 on the outside. Sweet. So this is not our inverse function just yet. We just need to consider which of the plus or minus we take. And that information is given in the domain of the original function. Because as I said in the previous video, the domain of the original function is going to be the range of our final function, or our inverse function, sorry. So if x is greater or equal to 2, that's going to mean that our range is going to equal y is greater or equal to 2. So I say that if y is greater or equal to 2, then I'm just going to say take positive square root. I'm not going to write the whole thing. I'm just shorthanded this, but you should specify the whole equation. You take or you reject the -1 because y is greater or equal to 2. Therefore, f inverse of x is going to equal the positive square root of 4, x plus 1, and then plus 2 on the outside. Sweet. So this is our inverse function here. It's a square root graph. And just note how these numbers look very similar. So you have a 4 there, 1/4 there, plus 1 there, minus 1 there, plus 2 there, minus 2 there. And that's actually an important consideration when learning inverse functions. It's hard to teach this when we learn inverse functions because we haven't learned transformations yet. But what we can see now is that we have a dilation by a factor of 1/4 from the x-axis. And what's this here? A dilation by a factor of 1/4 from the y-axis. So we're just swapping our axes, the same thing that we do with all of our inverse function properties. We just swap the x and y. And it works exactly the same way with transformations. Even the magnitude stays the same. This is dilation by a factor of 1/4. This is also a dilation by a factor of 1/4. This is just from the y-axis instead of the x-axis. If you look here as well, translation of 2 units up by adding on the outside, translation of 2 units to the right. So this one was the positive x direction, this one's the positive y direction. This is a translation of 1 unit downwards or in the negative y direction. This is a translation of 1 unit in the negative x direction. So even our transformations, it's in the same order and it's in the same magnitude of values. The only thing that's different is our axes are swapped. So that's just a really cool thing to note. And I have actually seen it in a couple of exams as well, where you really need to note that down. And it's actually it's a crucial thing for actually answering the question. So I'm going to cover it in more exam and SAC style questions when we get to it, because a lot of these concepts are kind of combined and mixed together when you do approach more SAC and exam style questions. It's hard to teach that in the theory videos just because I'm just expecting everyone to just want to learn that specific thing and learn them, independently, and then later we combine them together in a lot more greater detail. Sweet, so this is our inverse function, and we should just specify our domain as well. Our domain is just going to be the maximal domain of this equation. So we're just going to say x is greater or equal to -1. If you're struggling with that, just go back to the implied domain videos or just the, those types of videos in the domain and range section, and that'll teach you how to exactly find that one very quickly. Cool. So now we're asked to sketch both f of x and f inverse of x on the same axis. So it's really easy to just sketch our parabola because we know the turning point is going to be at 2, -1. So that's going to be roughly here. Sweet. And then that's just going to go upwards from there because we've taken the positive half. Awesome. So this is going to be f of x, and we're just going to find all the points later. Now this starting point here is going to be at -1, 2. How to get the turning point or the starting point for a square root function is exactly the same as a turning point for a quadratic equation. So you take the negative of this value inside the bracket and then the positive of the value on the outside. So it's going to be -1, 2. So it's going to be something like this. Just trying to keep everything in line and symmetrical. That boy can move a bit to the left there. Sweet. And then we have the traditional square root graph shape, which goes something like this. Cool. F -1 of x. I'm not going to write the full equation. It's not really necessary, but I definitely have to label all my key points. Now, we can find either the x-intercept of this one or the y-intercept of this one. The magnitude of that value is going to be the same. We just swap the x and y around. So I only actually have to find it once. I'm just going to do it with this value here because it's a bit easier. Don't have to rearrange anything. So I'm just going to say f -1 of 0 to find the y-intercept of this equation here. It's going to be 4 outside of 0 plus 1, and then plus 2 on the outside. The square root of 4 multiplied by 1 is a square root of 4, which is equal to 2, plus 2 on the outside is equal to 4. So therefore this means, that sounds right, 0, 4. This value is just very close to it. I think I just didn't do my graph very well, but that's okay. And this one will be 4, 0, because even our x and y intercept swap, so 0, 4, 4, 0. That should be good. I'm pretty sure that's fine. Sweet. Now, one more thing that we should find is the intersection between f of x and f inverse of x. So there's a couple of ways of actually doing this. The first way is just to rearrange or solve this equation equal to this equation. I'm just trying to think if my values are right. They should be right. Let's just assume they're right and keep going with this. I'm not 100% sure. I'm not super confident with this one. Let's just keep going anyway. So f of x is equal to f inverse of x. So you have a quadratic equation equal to a square root graph. Now, technically, this should give us the solution that we're looking for. Now, the only problem with this is that this is actually very hard to find because we're actually letting a quadratic equal a square root. So you're actually going to get a very complex equation to solve. So just don't forget that whenever we have a function equal to its inverse, we can just let one of our functions equal x and then solve the equation. Because the equation, or if you consider the graphical form, f of x is equal to f inverse of x, all of the intersections lie along the line y is equal to x. So instead we can solve f of x is equal to x or f inverse of x is equal to x, whichever one is simpler. It can give us the same solution anyway, but I'm going to go ahead and solve this equation equal to x because it's just a quadratic. This one might be a bit more complicated because we have the square root there. We're very used to solving for quadratic equations, so we're going to stick to this one here. I actually don't think this solution would be very good. That's why I was questioning it before, but it's okay. I just made up the numbers. I think, it's possible. So let's go ahead and solve this one. So we're going to solve f of x is equal to x. Let's just solve this very quickly because it's just a small part of this question. X minus 2 squared minus 1 is equal to x. So move the 1 to the other side and multiply by 4. So you end up getting x minus 2 squared is equal to x plus 1 multiplied by 4, which is equal to 4x plus 4. Cool. I'm not sure if the other camera will see this, but hopefully. X minus 2. Oh wait, we should expand this bracket actually, and then we just get a quadratic equation. Let's not use my finger for that one. Cool, so we just expand that bracket. X squared minus 4x plus 4 is equal to 4x plus 4. The 4's cancel out. So you end up getting, oh, this equation actually works out to be very good. We end up getting x squared minus 8x is equal to 0. Therefore, x outside of x minus 8 is equal to 0. Therefore, x is equal to 0 or 8. Cool. Now, x is equal to 0 is actually an irrelevant solution in this case because this is beyond the domain of this f of x graph here because it doesn't extend to that region anyway. So x equals 0, we can reject that solution. Therefore, our only solution is x is equal to 8. Now, what's the y value? Well, the line y is equal to x. It passes through, so we know the y value is going to be 8 as well. This is our line of symmetry here. So we've got y is equal to x. So therefore, our equation, or our intersection between our two equations, lies along the line, or lies at the point 8, 8. Now this is actually interesting. So this is our final solution. It's all good. We have all of our key points as well. We have x-intercepts, we have y-intercepts, we have starting points, and we have the intersection, and everything is labeled. Now let's do the origin as well. Why not? Now, why do we get x equals 0? Whenever I get things like this, I always like to question why we reject solutions, or maybe not why we reject them, but why we have them in the first place. And we know why we reject it, because it doesn't lie within our domain of f of x. But why do we actually get the solution x is equal to 0? Because we don't just get it randomly. It's not just some random solution. We get it for a specific reason. And the reason why we get it in this case, it's actually very interesting. It's because we've kind of neglected the left-hand side of this equation. Now we've said that the domain is going to be x is greater or equal to 2, so that's why we sketched the right-hand side. But the equation, or the algebra, doesn't actually know that. So f of x, it thinks that f of x is actually extending to the left-hand side. I don't want to ruin this graph because it's actually really nice. But just imagine this extending to the left-hand side here, and imagine this inverse function extending to this side here. We don't actually do that in this case because we want to keep it as functions, but imagine that we didn't have the restricted domain. So this would extend to there, just imagine that, and then the red would extend to there. Now, if we actually had both of those branches existing, then x is equal to 0 is actually going to be one of our intersections as well, because you can imagine this shape goes past there, and then this shape goes past there, and you can see them passing through at x is equal to 0. Hopefully you can imagine it as clear as I can right now, but just imagine that if this is extended and this is extended, then we pass through x is equal to 0 as well. But that's not valid in this case because of our restricted domains. Hypothetically though, if this was x is less than or equal to 2, then you would only have the negative branch, which therefore would mean you would have the negative square root, and therefore x is equal to 0 would be the only intersection, and x is equal to 8 would be neglected in that case. So the solution that we take, both solutions are technically valid from an algebraic standpoint, but we only took one in this case because x is equal to 8 is the only one that lied within our domain. But if we had a different starting domain, then we might take the other one as well. Well, we might take x is equal to 0, and in this case we would. It's not necessarily the case that you would take one or the other. Sometimes you actually take both intersections when it comes to finding inverse functions. In this case we only take one, and then the rejected one is a potential solution if we had the other side of our implied domain existing.